There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Faerie Fires. This is the way the module looks. It starts off as a blank module and all we simply need to do is we need to click the surface and what's going to happen here is that there's going to be 6 fairies appearing on the module. So let's take a look. Okay, and as you can see, they are doing sort of this little dance that they do. And what you want to do is you want to note down the pitch and the color order that they appear in. And a way that I like to do this is I like to get the color order that appears first, just to make our lives a little bit easier. But and now you can essentially click them and watch as they return to their houses, is what these are called. So you are able to freely click and cycle through these modules as much as you want to get the pitches and the color order. Let's do that again. So we've got magenta, cyan, yellow, blue, red, and green. And now they're going to be singing, and there's going to be the pitch that we need to get their voice. So we have 1, 2, 3, 4, 5, 6. I'm using the interactive, so thank you to Luminosity Kim, I believe, made this one. Yes, he did. Thank you very much for that. So now, here are the way that the pitches sound, and obviously this is a sound-related module. I'm sorry for those of you who are using sound. Thankfully, this module doesn't appear often yet. But it's a bit of it has to do with pitch, and I'm sorry about that. You're gonna have to bear with me, but this is the way that they sound. So 1, 2, 3, 4, 5, and 6. It's a bit weird. I'm sorry about that for people who are sort of tone deaf. I like to use the interactive to help you guys through this. I will be using this a lot during this tutorial, and hopefully you guys can hear the differences between the way that they sound. They are pretty distinct. 1 sounds like it's a deeper sound, and 6 sounds like a high-pitched sound. Yeah, sounds like a twinkly sound. So that's kind of the way that we're going to be looking at this. I obviously am going to go through a couple of runs of this just to make sure I get the pitches correct. But one other piece of information that we need from the bomb is we need the serial number, which will be relevant later on. So we've got November, Lima 1, Echo, Juliet 2. And for right now, we don't know exactly the pitches, but we do know the order of which they will be given, the colors will be given to us. So let's try and listen to this. I do believe it starts off with 6. Yeah, I do believe it starts off with 6 with magenta. So I think that we're going to mark this with the 6. 2. I want to say 4 and 5 for those last ones. Yeah, that sounds like 4 and 5 for red and green, respectively. Okay, so now we need to figure out 1, 2, 3 with cyan, yellow, and blue. Which, if we can figure out 1, I think that's going to be a good starting point. So let's do that. I think blue was 1. Blue sounded like 1. Let me make sure of that. I have a hunch that it's 3, 2. So now if we listen to this order, 6, 3, 2. Sounds something like that. Yeah, and just like that, we've determined our order of pitches. So that's kind of the way that I like to do this. This module is definitely not voice expert. I mean, it's fine on voice if you know how to do it, if you know how the pitches work. But now let's get into the actual work of this module. And this actual solving process is a little bit easy, but it's something that's something people are not going to be used to. So let's take a look and let's see what we need to do. So the first things first, what exactly is our goal with this module? So there's going to be a series of, we have to visit all of these fairies in some way, shape, or form. Because after the fairies have finished their dance, click on the surface and they will scuttle into their now illuminated houses, which is represented by these buttons over here. We're going to press the houses in the order of the fairies appeared at specific times. So it's always going to be the order of which we got the colors, because as you can see, if we go through this again, they'll leave their houses in this order, and they will return to their houses in that order. So if we go there, so now let's wait. I think it's magenta, cyan, yellow, blue, red, and green, just like we had previously. So we need to visit their houses, and but they're only going to be available at specific times because they have a very strict sleep schedule. We're only allowed to knock on doors when the last digit of the second timer is equal to their free time. And we have to do this for all 6. Now, determining this is not too hard. However, it's something that you might not be a little bit used to. So, to calculate the free time of a fairy, we're going to do the following. We're going to take the nth serial number character, where n is equal to their spot in the song, and append the first letter of their color. So, first things first, let's break this apart. So we need to take the nth serial number character, which in this case is why I got the serial number. And what we're going to do is we're going to take the spot that is represented by the pitch, And then what we're going to do is we're going to append the color afterwards, the first letter of their color afterwards, which in this case, color names are pretty easy to know. Red, green, blue, yellow, cyan, and magenta. But it's very important that you use those instead of something like turquoise or anything, or purple for magenta. It's very important that you know that there is actually a correct color name for these. So let's take a look. So for our first one here, we have position 6 with this pitch here. We have number 2. We have in this case the 2 is in the 6th position, so 2. And then now what we're going to do is we're going to append the first letter of the color, which in this case append means add to the end, and we're going to append the magenta. So in this case, to Mike. And we're essentially going to be doing this for all 6 colors. So let's actually pop this up here, and let's do this. So we have position 3, which is a 1, and cyan, Charlie. We have position 2, which is a Lima, and then yellow for Yankee. Position 1 is a November, and we have blue, which is Bravo. Then we have position 4, which is Echo. Red is Romeo. 5, which is going to be Juliet. And then we have Golf for green. Okay, and this is what we need to do with this module. So now, these represent base 36, a base 36 number. And what we need to do is we need to convert these guys into base 10. And this is a really simple process. For those of you who are not familiar with how base 36 works, essentially what this is that we have the range of 0 through 9. And then what we have here is then we have A through Z afterwards. So in this case, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it goes into A, B, C, D, E, F, G, and so on and so forth. All the way to Zulu, which in this case represents 35. So this is essentially what we're going to be doing here. And the way that you can calculate, for example, the letters is nice and easy to do. It's the alphabetic position of that letter. In this case, let's take Mike, for example, 13. And then all we simply need to do is we simply need to add 9 to it, just like that. And also, for example, alpha is going to be 1 plus 9, which in this case is 10. It appears right after 9, so that makes sense. So this is essentially what we're going to be doing. But also, because we're dealing with 2-digit number, what's going to be happening here is that these numbers represent something. These represent 36 to the power of 2, or 36 to the power of 1, rather. So now what we're going to do is we're going to multiply this, multiply our first value by 36, which in this case 36 to the power of 1 is indeed, you guessed it, 36. We're going to multiply the first number by 36, and then we're going to add on the second digit, in this case in base 36. 36 to the power of 1, and then 36 to the power of 0, which represents 1. So in this case, it's like 2 multiplication things. So we've got 2 times 36, and then we do, in this case, for those of you who don't know, anything to the power of 0 is always equal to 1. Then we have Mike times this by 1, which in this case we agreed was 13 plus 9, which is going to be 22. And this is essentially all you're doing here. So 2 times 36 is going to be 72, plus the 22 we get is going to be 94. And these are going to represent the numbers that we have here. So 94. And we're going to do this with all of these guys. So we've got 94. Let's do the same thing. So 1 times 36 is, you guessed it, 36, plus 3 plus 9. So that's 48. Then what we have here is we have a 12 plus 9, which is Lima. Then we're going to multiply this by 36. Then we're going to have we're going to add 25 plus 9, which is going to be 790. Then we have 14 plus 9, times by 36, plus 2 plus 9, 839. Then what we have here is our next one. We have a 5 plus 9, times by 36. And then we have 18 plus 9, 18 plus 9. 531. And finally, for our last example here, we have a 10 plus 9 times by 36, and then adding 7 plus 9. Okay? And that's going to be totaling to 700. Now we get to the weird part of this. So now what it wants us to do is then we've already converted these from base 36 to base 10, which we just did here. And now what we're going to do is we're going to apply the median difference to it. What exactly is the median difference here? The median difference is explained down here at the bottom. Take any number and calculate the absolute differences of their internal neighboring digits, and repeat until one digit remains. And it provides an example down here, which I would recommend using. So what exactly is going to be happening with this thing? If we take a look here, what it essentially does is it takes 2 digits together, in this case the first digit being the 1 and the 2, then the next being the 2 and the 9, then the next being the 9 and the 4, essentially forming as many possible digits possible. So we have 1, 2, 9, 4 example here, and then it says 1, 2, 2, 9, and 9, 4. So essentially what's going to be happening here is it's going to be focusing on 2 digits at a time. And what's going to happen here is that we're going to essentially be taking the difference between these values, and we're going to be doing this until we have one single digit left. So now the result of this, it totals out to 175, but it's not addition or anything that's happening here. What's happening here is that each of these numbers are doing essentially subtraction, and they're taking their differences between them. In this case, the difference between 2 and 1 is going to be 1. The difference between 2 and 9 is going to be 7, and the difference between 9 and 4 is going to be 5. We do the exact same thing for this one, 1775. The difference between 1 and 7 is going to be a 6, and the difference between 6 and 5 is going to be 2. And then, as you can see, it's exactly following along, and the difference between these two values is a simple difference of 4. And that's the way how this thing works. So now, essentially, what we're going to be doing here is we're going to be doing the exact same thing for all of our digits, and we'll get that single digit that we need to hit, because that's going to be what we're going to do for when we press the last second digit every time. So, we have 9 and 4 with a difference of 5. That's it. 4 and 8 have a difference of 4. 7 and 9, and 9 and 0, so 7, 9, and 9, 0. We have a difference of 2, and we have a difference of 9. Then 2 and 9 have a difference of 7. Just like that, that value's been determined. Then we have 8, 3, and 3, 9. 8 and 3 have a difference of 5. 3 and 9 have a difference of 6. These guys together have a difference of 1. That one's been determined. 5 and 3, 3 and 1. These guys have a difference of 2. These guys have a difference of 2. Now, these guys are both 2. They both have a difference of 0. Perfect. 70, and then 0, 0. Both have a difference of 0. That's 0. 7 and 0 have a difference of 7. 7 and 0 have a difference of, you guessed it, 7. And now, these are the values for each of the colors that we're going to be pressing when the last digit is present in the timer. So now we're going to press magenta on 5. Okay. Cyan on 4. Just missed it. We'll wait. Then yellow on 7. Okay. Then yellow on 7. Then blue on 1. Then red on 0. We'll do this quick. Okay. And then finally green on 7. Just like that is a solved module. So it's a little neat module, it's a little neat concept. That's all it really is to it. It's just making sure that you understand how the median difference works. It's a very interesting concept that I don't think I've actually seen in any other manual except this one. But it's not something like digital root. It's not something like that at all. And it's actually quite simple to do. So just don't be intimidated by that. The hardest part of this module is honestly getting the pitch. The rest of the work is just base conversions and then doing that median difference. So I will go over one more example and we'll be good to go. Also, shoutouts to me thinking for the longest time that this was fairy flies, not fairy fires. Just thought I'd point that out. And for the longest time, I thought this was fairy flies. I thought it was just... I'm not going to question it. Blue, green, cyan, red, magenta, and yellow. Blue, green, cyan, red, magenta, and yellow. Perfect. Okay. Now we need to determine the pitches for these guys. I think the first one was 1. Hear that? Okay. That last one? That's a 2, yep. I'm trying to figure out what that second one is. I want to say that's a 4. Okay, 3, 4. Yep. And I want to say that 6 is red, and then you're 5. Let me make sure of that. So it's gonna sound something like this. Yeah, that's exactly what I just played. Cool, awesome. So now let's get our serial number here, and let's start doing what we just did beforehand. Okay, we have 5 Tango 1, Tango Papa, Hello Twitch Plays, 6, and let's take a look and see what we need to do for this. So, again, we need to convert these guys into base 36, but we need to actually group these guys together first. So we've got position 1 is going to be a 5, And then the color that corresponds to it is Bravo, which is going to be blue. The next step we have position 3 is going to be 1, and then Golf. Position 4, Tango, and then Charlie. Position 6, 6, and then Romeo. Magenta is 5, so that's going to be Papa, and then Mike. And then 2 is going to be Tango, then Yankee. Okay? Now let's convert these guys into base 10. So we've got 5 times this by 36, plus 2 plus 9, 191. We've got 1 times 36, plus 7 plus 9, nice and easy, 5 and 2. We can also just do this internally, so we have actually 1 and 9. 1 and 9 is going to be a difference of 8. 9 and 1 is going to be a difference of 8, and this is going to be a difference of 0. This is going to be a difference of 3, 5, and 2. The next step we have 20 plus 9 times this, times this by 36, so 29 times this by 36, big, plus 3 plus 9 is going to be 1056. This one's going to take a little bit of work, 1056. We've got difference between, we've got in this case, 100556. Let's break this apart. We have 1, 5, 1. So the difference between 15 and 51, in this case, that's going to be 4 and 4. And this is going to be 4, 4. It's going to be a difference of 0. Okay? Then we have a 6 times this by 36, plus 18, plus 9. It's going to be 243. 243, this is going to be 24, and then 43, difference of 2, and then difference of 1. Difference of 2 and 1 is going to be 1. And what we have here is 16 plus 9, times this by 36, 900, plus 13 plus 9 is going to be 922, 92, 22, 0, and then that's going to be a 7. So 7 and 0 is simply going to be 7, okay? And then finally, for the last one, we have 20 plus 9 times this by 36 is going to be 1044 plus 25 plus 9. So 100778. We get a difference of 1, we get a difference of 7, we get a difference of 1. Then we do 1, 7, and 7, 1, and you can kind of already see where this path is going down. Difference of 6, difference of 6, 6, 6 has a difference of 0. And just like that, we have done all the work that we need to do. So now we start with blue. Blue is going to be pressed on 0. Okay. Green is going to be pressed on 3. Cyan is going to be pressed on 0. Green 3, cyan 0. Okay. Red 1, magenta 7. Yellow 0. Just like that. This is solved the module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.